Myself, Dr. K. Viswanath Allamraju, Minister of Aeronautical Engineering, Department of Mechanical Engineering, Hyderabad. Today we are going to study the inversions and the concept of inversions and inversions of slider crank chain mechanism. So what is inversion? Inversion means by fixing different links, obtaining different mechanisms is known as of a kinematic chain is known as inversion. Once again, what is inversion? Different mechanisms are obtained by fixing different links of a kinematic chain are known as inversions. Suppose if you take a 4-bar mechanism, a 4-bar chain, this is link 1, 2, 3, 4. In this 4-bar chain, by fixing link 1, what is happening here? The link 2 is considered as a rocker and link 4 also becomes a rocker. So this is one inversion. And remove the link 1 and fix link 2. Then it will obtain a different mechanism. That is called a different inversion. That is second inversion. If you fix link 3 and give motion to any one of the link, different output will be obtained. Then that is called third inversion. Similarly, if you fix link 4 and free other links and give any motion to any one of the link, then it will obtain another motion. Then that is fourth inversion. So it is a 4-bar chain. The 4-bar kinematic chain consists of 4 turning pairs. The 4-bar kinematic chain consists of 4 turning pairs. If you remove one of the turning pair and replace with sliding pair, this is the link 1, 2, 3, 4. I am going to remove this turning pair with sliding pair. Then what will happen? If you keep the slider, then becomes then link 2 becomes a crank, link 1 is fixed, link 3 is a connecting rod, and link 4 becomes the slider. Then it is called slider crank mechanism. Slider crank mechanism. Alright. Now that is what the concept of slider crank chain is. So when one of the turning pairs of a 4-bar chain is fixed, is replaced by a sliding pair, then it is known as a sliding crank kinematic chain, or simply single slider crank chain, or simply a slider crank chain. So if you replace the two turning pairs with 2 sliding pairs, then it is known as the 4-bar chain to get a double slider crank chain. Double slider crank chain. So in a slider crank chain, the straight line path of the slider may be passed through the fixed pivot O or may be displaced. The distance E. Now very important concept is that what is offset? Offset means, suppose it is a slider. The line of action of the pivot O and the line of path of a slider, the distance from pivot O to line of path, then it is E. That is called offset. E is the offset. E is offset. Now suppose if the line of path of the line of slider is coincidental with the fixed link pivot O, then offset E becomes no offset, then E becomes 0. If E is 0, that means These both are on the same line. The pivot center is coincidental with the line of path of slider. Thus, we can see what is zero offset, what is offset. This is the positive offset. It is above in, okay, that is the positive value. What is zero offset? The zero offset means zero offset, a negative offset. The negative offset is, this is the line of path, this is E, this is negative offset. So there will be positive offset and there will be negative offset and zero offset. These three are the concepts. If you understand these concepts, we can understand better what is inversion of kinematic chain. Now, there are four inversions are there. We have four inversions. First inversion, if the inversion, this first inversion obtained when link 1 is fixed. When link 1 is fixed, first inversion will be obtained. And in this case, if you see, there are two applications of first inversion. Number one is reciprocating engine and figure B shows reciprocating compressor. There are two inversions. These inversions are obtained by fixing what? The first inversion is obtained by fixing the link 1. In the case of reciprocating engine, here very important is that whatever application may be, the applications are representing the first inversion. First inversion means link 1 remains fixed and link 2 becomes, what is the link 2 becomes? Crank, and link 4 is the slider. Now, if you see the figure here, in this figure, reciprocating engine, in this reciprocating engine, what is the driver? The piston, the slider, link 4 is the driver. That is the piston, slider. The slider is the driver and a crank is driven. The crank is driven. The crank is driven, that is the crank 2. Alright. Driver is, this is the driver, link 4 is the driver. Crank 2 is driven. Driven member. Driven member. Now, whereas in the case of reciprocating compressor, what is it driven? What is it driven? The driven is piston and the driver is crank. Crank is the driver here. Okay. The driven member in the case of reciprocating engine is the crank. Driver member is a slider. Here in the case of reciprocating compressor, it is reverse. Reverse in the sense, the crank becomes a driver, link 2 becomes a driver, link 4 becomes driven member. Now, very important here, in this animation, we can see the driver and the driven. The crank is the driver and the driven is the discharge. Here, the piston position is the driven member. So, this zone is the input zone and this zone is output zone. Okay, this is output. Now, discharge. Here, that is the output where discharging is taking place, suction and discharge valve. Now, that is the first inversion. In the first inversion, again, let me summarize. This inversion results when link 1 of a slider crank chain is fixed. Link 2 and link 4 becomes crank and slider. The applications of first inversions, number 1, reciprocating engine, and number 2, reciprocating compressor. In the case of reciprocating engine, the driver member is slider, driven member is crank. And in the case of reciprocating compressor, the driven member is the driver. So the driver member is, in the case of reciprocating compressor, the driver member is the crank, driven member is piston or slider. So by considering applications, by considering changing the input and outputs, the complete application has been changed. Now, what is second inversion? The second inversion results by fixing link 2, fixing of the link 2 of a slider crank chain. Okay, then it results second inversion. There are two applications for second inversion. Based on this inversion, two applications we can apply for two mechanism, for two kinds of machines, structures we can use it. So this mechanism is called Whitworth quick return mechanism by using this inversion. And next one is rotary engine. In the Whitworth quick return motion mechanism, what link? Link 2 is fixed. This is the link 2 fixed that figure B indicates. Again, there are 4 links are there. By adding extra attachments, link 1 is extended further and attach link 5 and give it another tool, that is 6 and it is 5. And how many links are here? How many links? There are 6 links are here. Okay, these 6 links, this is 6-bar mechanism we can call it. But the inversion used for this is single slider crank chain by fixing link 2. Now what is happening here? Coming to figure C. So when link 2, which was acted as a crank in the first inversion, it was fixed. Then what link acts as a crank? Now that position is taken by link 3. Now link 3 acts as a crank, rotates about A. And link 4 slides on the link 1. Such a way that when crank moves from B dash to B, A, B dash, A, B double dash. This is the path. Then it becomes the angle turned by the crank is a theta, that is obtuse angle. During that time, the C moves from C dash to C double dash. At that time, link 5 and 6 moves from Y to Y double dash. That is called forward stroke. Forward stroke. Then again it completes another revolution, that is B double dash to A to B dash. Then return stroke takes place. Then it moves backwards. Cutting tool moves. That is called return. That is return stroke. Cutting stroke, forward stroke, return stroke, idle stroke. So cutting stroke is the forward stroke and return stroke is the idle stroke. So how can we represent the time of cutting and the time of return? It can't be measured because it takes place very quickly. Okay, that's why it's called quick return motion. Whitworth quick return motion mechanism. Very quickly it takes. You can't find out what is the forward stroke. Yes, this much. Then return stroke. No. It happens very quickly. Then how to measure it? This time of cutting ratio, and it should be applicable to the mechanism. So to second inversion. So what is the second inversion? Here what are the quantity parameters are there? Theta and beta. So time of cutting to time of return, that is equal to cut time ratio. The time ratio is represented in terms of angle turned during cutting stroke by angle turned during return stroke, theta by beta. It is in terms of radians. In terms of radians, alright, that is theta by beta. Thus, we understood the mechanism of Whitworth quick return mechanism function working. What is second? This slide indicates in briefly what is Whitworth quick return mechanism. Okay, this ram attached, this tool is attached to ram. During forward stroke, it moves y1 to y1 to y2. Return stroke moves y2 to y1. Thus we can understand the working of Whitworth quick return motion mechanism. Now, what is second example for this quick return motion? The second application for second inversion of the single slided crank chain is rotary engine. In this rotary engine, what will happen? Again, same second inversion. Link 2 is fixed. Link 2 remains fixed and the link 3 acts as a crank. And here link 1, we modifying it, but function remains same. So link 1 become a cylinder and link 4 become a slider. So what will happen? Link 2 remains fixed. Then link 3, that is crank, acts as a crank. This is 3-cylinder rotary engine. There are different types of rotary engines, 3-cylindered, 7-cylinder and 9-cylindered. So that means what? Link 1 is not fixed. That means link 1 is also moves. And what are the moving members here? Moving links are, movable links are link 3, link 4 and link 1. And link 2 remains fixed. That's why it becomes second inversion. Let us read what the description is given in the textbooks. So in a rotary engine, the slider is replaced by a piston and the link 1 by a cylinder pivoted at O. Moreover, instead of one cylinder, 7 or 9 cylinders symmetrically placed at regular intervals in the same plane or in parallel planes are used. All the cylinders rotate about the same fixed center, point A, about point A, from a balanced system. The fixed link 2 also common to all cylinders. So, in the case of rotary engine, the crank 2 is fixed and the body 1 rotates. Whereas in the case of reciprocating engine, first inversion, the body 1 is fixed and the crank 2 rotates. Let us see here in this slider. So, in order to make it understand, this is 7 cylinders. You can see how all the cylinders are rotated. And here in the case of this is 3 cylinders and it is 9 cylinders. 9-cylinder rotary engine. In the case of 9-cylinder rotary engine, you can see how the common is the crank remains fixed. The crank is fixed here and the cylinders are moving. Okay. Thus we can understand the application of second inversion, that is rotary engine. Next, what is third inversion? Third inversion is obtained by fixing link 3 of a single slider crank chain. What are the applications? Again, there are two applications are there. Number 1, oscillating cylinder engine, and number 2, crank and slotted lever mechanism. This lever mechanism is very, very important for daily application, especially in shaping machines. And it is very important for examination point of view also. Now let us read. Yes, the third inversion is obtained. Now, what is the position? Link 1, 2, 4 are under movable condition, moving condition, free from fixed. Link 3 is fixed. Link 3 is fixed. Now, the link 2 again. By fixing the link 3 of a slider crank mechanism, the third inversion is obtained. Now, the link 2 again acts as a crank. Link 2 again acts as a crank. And link 4 oscillates. Now, figure B indicates the oscillating cylinder engine. Okay. In this oscillating cylinder engine, that meaning itself denotes cylinder. Link 4 is under oscillation and link 2 is under rotation. And remaining links supports and link 3 remains fixed. And link 1 helps. Link 1 is attached. A piston is attached to link 1. So, what is the driving member and the driven member in this mechanism? The driving member is here or cylinder. This is the position. Piston moves due to oscillations. At that time, what will happen? The crank rotates. This is the driven member. Driven member. Alright. Thus, we can make it. We can understand the concept of oscillating cylinder engine. Further, we can see in animation view what is happening, where it has, how the oscillating taking place. Okay, these oscillations makes to rotate the crank complete revolution. So it has 3 turning pairs and 1 sliding pair. So the link 4 is made in the form of a cylinder and a piston is fixed to the end of the link 1. Yes, link 4 is made in the form of a cylinder and link 1, a piston is attached at the end of the link 1. The piston reciprocates inside the cylinder pivoted to the link, fixed link 3. This arrangement is known as oscillating cylinder engine, in which as the piston reciprocates in the oscillating cylinder, that is the driving member and the driven member is the crank. The crank rotates and the crank rotates. So this is the third inversion, first application of a slider crank chain. In this slide you can see how the oscillating cylinder mechanism can be used for a steam engine. This is a steam engine with oscillating cylinder. You can see the steam input is circle red color and output is the blue color. So how the steam entering and piston is moving, and when piston comes back, steam goes out. But during this time, the crank rotates, rotation takes place. Okay, that is the third inversion. Now, very important mechanism is crank and slotted lever mechanism. So this mechanism is a third inversion of a single slider crank chain. Third inversion of a single slider crank chain. So here you can see what link is fixed again. Third inversion, third link is fixed. And link 2, crank acting as a crank. And link 4 is supporting to slider 1. And link 5 is the connecting. So link 5 and 6. Now what is happening here? Again, link 2 rotates about point A. At that time, the link 2 is attached to link 1, is the slider. It pulls the link 4 along with, it obeys link 2 motion. So it moves. So it cannot rotate completely because it will oscillate. Oscillations takes place from this position to this position. Oscillations. Suppose if link 2, if you observe figure B, from A dash to A double dash, this is A. A dash, A double dash, that is theta, obtuse angle. That is angle, obtuse angle theta. That obtuse angle, during that time, the tool cuts the material, removes the material. That stroke, the displacement of the tool during that obtuse angle is known as forward stroke or cutting stroke. At that moment, material will be cut, and when crank rotates completely, then what happens? From it goes back again, comes back. Then that is remaining revolution, remaining angle, it comes back, cutting tool comes back. That is return stroke or idle stroke. cutting stroke. Next one is ideal stroke. So how to measure these angles? The time of cutting, time ratio. Time ratio equal to time of cutting by time of return. That is in terms of theta by beta. Angle of obtuse by angle of return. Acute angle, theta by beta. Thus, we'll find out time ratios of the motion of a crank during cutting and return of a crank and slotted lever mechanism. The application of this slotted lever mechanism is again where it will be applied, this type of mechanism. In the case of shaping machines, shaper. In the case of shapers, this mechanism is used. Now there are two applications. First, the third inversion application is crank and slotted lever mechanism. The application of crank and slotted lever mechanism is shaping machine. Thus, we will use in various machines quick return motion mechanisms. This is also quick return motion. The time of cutting is more than the time of return. That's why time ratios are greater than 1. Time ratio is greater than 1. Okay, that is time of cutting by time of return. Next, the next final inversion is fourth inversion. In the case of fourth inversion, we can see here how the fourth inversion results. Fourth inversion will be obtained by fixing link 4 of a single slider crank chain. What is single slider crank chain? Again, link 1, 2, 3, 4. Fix link 4. Then that is modified, turned it and extended to this one as a attached, the piston. Then what will happen here? So if you turn it, yes, turn the angle, then it will be obtained. This is the mechanism. The application of the fourth inversion is hand pump. In the case of hand pump, the cylinder 4 is made as a hollow supporting, that is at the surface, and attached to that link 3, and link 1 is attached to the piston. When link 2 oscillates up and down motion, then what will happen? This piston goes down, up and down motion. So what will happen? It is used for discharging the water in a hand pump. Now the water is being discharged in this animation, you can see it. So if the link 4 of the slider crank mechanism, the description given here is fixed, the fourth inversion is obtained. Link 3 can oscillate. The link 3 can oscillate about the fixed pivot B on the link 4. This makes the end of the link 2 to oscillate about B and the end O to reciprocate along the axis of the fixed link 4. Fixed link 4. The link, which link is fixed here? Link 4 remains fixed. Link 1, link 2, link 3 remains under motion. What type of motion? Whether it can be a oscillation, it can be a translation, it can be a rotary motion. So oscillation means not complete rotation. Alright, is a partial rotation is called known as oscillations. So that is the example for fourth inversion, the application of fourth inversions. Now here, very important is that all these inversions are mentioned. It is only for single slider crank chain mechanism only, not for double slider crank chain mechanism. Again, if we consider double slider crank chain mechanism, by fixing the different links, different mechanisms are obtained, then it is known as inversions of double slider crank chain mechanism. We discussed in this class only single slider crank chain mechanism. Now coming to apply the degree of freedom concepts, all these inversions. What is the degree of freedom? let us begin. How to calculate the degree of freedom of all these mechanisms? If you apply the degree of freedom concept for these mechanisms, based on the principle of Grubler's criterion, what is the formula? That is 3 into degree of freedom equal to 3 into n minus 1 minus 2 times lower pace minus higher pace. So what is the degree of freedom for this mechanism? So link 1 is fixed. How many links are there? There are 4 links are there. How many lower pairs are there? So there are 4 lower pairs are there. How many higher pairs? The higher pairs in this mechanism is 0. So the degree of freedom is equal to 1. That is the degree of freedom. So what is the significance of this degree of freedom? Of first inversion. Degree of freedom first inversion is equal to 1. So the degree of freedom concept is based on the number of links, number of lower pairs and number of higher pairs. So in this all inversions, the higher pairs, the number of higher pairs is equal to 0. But what are the number of lower pairs and number of links are modified. But all are having all are lower pairs and number of links are modified. Now that is the degree of freedom for the first inversion. Next, what is the degree of freedom of second inversion? Yes, in this case we understand how many links are there. How many links are there? The number of links, n equal to 6. How many lower pairs are there? Lower pairs are 1, 2, 3, okay, 4, 5, 6. L equal to 6. How many higher pairs are there? 0. Substitute back in the formula. 3 into n minus 1, 3 5s, 2 6s. H equal to 0. 2 into L. Yes. Now, how many lower pairs? The degree of freedom, if you consider it, it is coming as how much? 3 into 5 minus 3, 5 is 15 minus 12, 3. No. Now, we have to consider our attempt. It may be the number of links remains 6. But number of lower pairs, we have to consider it. But it should come as 1. Then it is only called a single degree of freedom system. Why single degree of freedom system? The single degree of freedom means if you give the number of inputs to any one of the links, the definite direction output will be obtained. Output that remains constant. So how many mechanisms here, if you understand? 1, 2, yes, 1, 2, link 1 and 2, fixed link, there is a fixed link 1 to 1 pair, 1, how many lower pairs are there? This 1, 2, and it is 3, correct? It is 4, and it is 5, and between fixed link to this 6, and anywhere there is any motion, 6, L equal to 6, and one more here, yeah, 1, 2, 3, sorry, it is the ternary, yes, ternary join. Now what will happen? 1, 2, 3, so L equal to 7. If you substitute L equal to 7, 2 7 is 14, then the degree of freedom equal to 1. Yes, correct. So all inversions, if you apply, what is the inversion of rotary engine? It is remains same. The degree of shear freedom value for a single, all inversions, the degree of freedom is equal to 1. Okay, that is a slider. These are inversions of a single slider crank chain. So the degree of freedom of all inversions of a single slider crank chain is equal to 1. Now, let me conclude in this session what we have studied. We have studied the inversions of single slider crank chain. The first inversion, by fixing link 1, first inversion is obtained. The applications of first inversions are reciprocating engine and reciprocating compressor. And by fixing link 2, second inversion is obtained. The applications of second inversions are Whitworth quick return motion mechanism and rotary engine. And by fixing link 3, third inversion is obtained. And what are the applications of third inversions? The third inversions are oscillating cylinder engine and crank and slotted lever mechanism. And fourth inversion is obtained by fixing link 4 of a single slider crank chain. And what is the application? That is the hand pump. This hand pump technology is used for discharging the water from ground level to for usual domestic purpose. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.